Okay, I'm going to do one more example of an epsilon delta proof to prove that the limit as x approaches 2 of negative 2x plus 1 is equal to negative 3. So for this example, my c here is 2, my f of x is negative 2x plus 1, and my L is negative 3. So just like before, we're going to start by letting epsilon greater than 0, the easiest 2 points you'll ever earn. And we're going to assume that the absolute value of x minus c, so that's x minus 2, is between 0 and some delta. We'll figure out what that is in a minute. And I'm going to get down to the fact that the absolute value of f of x minus L has to be less than epsilon, so I can say, by the definition, the limit as x approaches negative 3 of negative 2x plus 1 as x approaches 2 of negative 2x plus 1 is equal to negative 3. So let's come over here and we're going to do our scratch work. So we're going to start with the absolute value of negative 2x plus 1 minus negative 3 is less than epsilon. And we're going to simplify. So this is negative 2x plus 1 plus 3. And the the 1 plus 3 is going to be 4. And I'm going to pull the negative 2 out, which leaves me with x minus 2. And that is an absolute value part right there. So that breaks down to the absolute value of negative 2 times the absolute value of x minus 2. And the absolute value of negative 2 is 2. So if I divide by 2, I get that the absolute value of x minus 2 is less than epsilon over 2. And we're going to let that be our delta. We're choosing that to be our delta. So I'm going to write that here. Delta is epsilon over 2. So now we fill in the middle. So we're starting off with the absolute value of negative 2x plus 1 minus negative 3. And that is the absolute value of negative 2x plus 1 plus 3, which is the absolute value of negative 2x plus 4, which is the absolute value of negative 2 times the absolute value of x minus 2. You can show a little bit less detail in this side if you want to, which is equal to 2 times the absolute value of x minus 2, which is less than 2 times epsilon over 2, coming from our assumption here. We're just filling that in. And this is equal to epsilon because those cancel. So starting here, less than here, we have that what we needed, and we are done. So this is an epsilon delta proof of a limit.